Hi everybody, welcome again. My name is Zekeriya Eskioджак. I have been working in Palo Alto Networks for 7 years, and I remember last year we had also a similar topic here discussing the segmentation for the data centers. I would like to share with you how the security in our infrastructure, in our network, has been evolving, and how the business requirements are forcing the IT to change the things in our data center, what are the security risks and how we can address them, mainly from architectural point of view. Before starting to that, I want to share with you some numbers. This is something I've found in some reports published publicly. I've shared the links. The average cost of building a new data center in the US is around $215 million. This is a research done by US chambers. If you look at the cost of security breach, this is real data taken from reports about two multinational companies, large enterprises. They had the security breach, and the final cost of them was around $100 million. So what does it mean for us? If such security breaches in such multinational companies can be prevented, the saving that they could make, two of them can build a new data center for them. That's much important, having the security our business enabler. Another statistics that I want to share regarding the average cost of the security breach. The annual cost of power consumed in a data center, around $7.4 million. This is the power consumption cost in average. The average cost of the security breach based on the 2019 statistics, around $8.19 million. So it means if you can prevent one security breach, you can use that money for spending for your energy in your data center for 1 year. That's why we should look in deeper on how we can make our data center design better to prevent the security breaches. If you go back to maybe 15 years from now, how we used to secure our perimeter. It is, very basic. We have the untrust, the internet, we have a router and the firewall behind the router. We were controlling the ports and the IPs. If you look at TCP port 80, it means for us, used to mean for us, the web server sitting in the DMZ. TCP 25 used to be the mail server, and if I grant access or deny the access, I control the traffic going back and forth. But the reality is not like that anymore. The IP doesn't mean it is that user. The source destination IP protocol controlling doesn't mean you are controlling all the applications. And we started to face with known and unknown attacks in the perimeter. What Palo Alto Networks did is we came up with a new idea, the next-gen firewall, and we start to control the application, the user. We start to do the content inspection with our single pass technology with high performance, and we provided the updates from the cloud continuously, like IPS signatures, like antivirus signatures, URL filterings, domains. Recently, as you listen to Alexander in the new features, we introduced the DNS security services, part of our next-gen firewall. All of these things helped us to secure our perimeter. But the business requirements continuously were increasing and forcing us to look for something else. The DMZ, the servers sitting in the DMZ, is not enough to provide to help the digital transformation. We needed something bigger, and we needed we built our data centers, part of our network. We extended our network to data centers, having different servers sitting in different VLANs, and we put a big layer 3 switch, and we routed the traffic inside the data center through the switch. But if one of these segments being infected with a malware or virus, it is very easy to spread and go all around the network and infect every host. It creates a big problem for us in this case. What we needed to do is to make sure that our data center, the segments, talk to each other in a secure way. We call it the zero trust networking principle. In order to do that, we introduced the next-gen firewall for the data centers. We can scale up to more than 300 gigabit per second, while you are enabling all the security features like controlling the application, the user, the content, the malware, everything. So what we do here is, as we do in the perimeter, we do the security checks in the data center, we segment the network, the physical network, and we make our firewall is the default gateway for all the networks. Therefore, if anything happens in one segment, cannot be propagated to other segments. We have the visibility. We see all the traffic crossing from one segment to another, or crossing from the segment to the internet, or coming from the users from our local network to the data center. We can control the admin access, and if there is any admin being hacked, we can still take action and not allow the admin directly accessing the resources. We can leverage our multi-factor authentication to control the access to the critical resources. We call it segmentation based on zero trust networking principles. But the business drivers all the time were changing, and we faced with the requirement of having virtualized data center in our private network. You know some of the vendors, I named them, but there are more. VMware, Cisco, Nutanix. These vendors came up with the idea that you can leverage the hardware, you utilize the hardware in a better way, you can manage your traffic based on a software-defined network principle. In this case, what happened is, what we were doing in the physical segments, yes, it was good, but now we have something inside the segment, traffic crossing between the VM machines, VM servers, without even going to the physical network. We don't see those packets in the physical network, therefore we cannot control them. And if we have any infection, same scenario here in the virtual environment, if we have any infection on one of the VMs, that infection, that malware can easily propagate inside the virtual network, and we cannot see it, we cannot understand what's going on. What we needed now is to go one level deeper and see how can we control the traffic inside our virtual environment. How we can do that? We have the hypervisor, we have the virtual switch. What we needed is to have the firewall, the same feature sets, available in the virtual environment on top of the hypervisor. And we interacted with the controllers that control the traffic and configure the switches to understand the context of the VMs, to be able to take the packets and forward them to next-gen firewall first, and then allow them or deny them based on the configuration. So all the functionalities that were available in the physical network, now available in the private virtual network. So we call it the micro-segmentation. We are not in the physical network anymore. We are still there, but for this scenario, we are inside the virtual network on top of the hypervisor and seeing all the traffic crossing. We call it east and west traffic. We integrate with Cisco ACI, we integrate with NSXV, NSXT, or in the OpenStack environment, with any SDN controller, we can interact through the APIs. I don't know if anybody of you are using the containers, but the virtualization didn't stop at the VM level or at the server level. The virtualization, the business requirement forced the ITs to find ways to be more flexible, more scalable, more agile. And the solution was the containers. So we start in the field to see that the enterprise customers start to virtualize even the operating system itself and having different applications running on different containers on the same VM or physical host. What happened now is we lost the visibility and control on the virtual switch. The traffic starts to cross between the apps in the container, between the containers, on the container hypervisor. We needed to go more deeper in this case. So that the virtual switch, what we were seeing in the VM firewall sitting on top of the hypervisor, is no longer able to see the traffic crossing between the two apps in the same operating system on the same, let's say, Docker. What we needed is to have more control and visibility over the apps. We acquired a company called Twistlock. Now we call it the Prisma Compute solution. This is a container image running on a container hypervisor and controlling the traffic between, crossing between the applications, the images themselves. So for the runtime, if an application talking to another application, we can see that traffic, we can report it, and we can do firewalling for that. And it's not only about that, it's about also shifting the security from right to left, means not waiting until the traffic comes and run and hit the vulnerability. We are able now to do scanning during the development. We support the CI/CD, continuous implementation and development, deployment. And in this phase, we can allow or deny images to be running on the hypervisor. So it is two-part: scanning the images and preventing unsupported or non-compatible from security perspective images to be run, or if the images are already running, controlling the running, the traffic coming in and out through the applications. If we call it, we can name it like nano-segmentation. We start from segmentation, micro-segmentation. We can name it nano-segmentation. It's not official name, but this is what I call it. If you go to the enterprises that they want to expand and extend their capabilities in the data center, we see that there are there is a move to the cloud in the same time. Not 100% moving all the applications to the cloud, having the private cloud in the data center, along with the public cloud, so a hybrid model. This is the common model that we see. Now, when you go to the public cloud, like getting support or getting renting resources from, let's say, AWS, Google Cloud, or Azure, or Alibaba, anyway, the infrastructure itself, it is secured by them. the infrastructure. But whatever you install in the infrastructure, a VM, an application, it could be the Windows server, an application running on Windows server or Linux server, or whatever, it needs the same security protection like you do in your physical network. Why? Because if you look at the infrastructure provided by your vendor, cloud vendor, you have the router, virtual router, and you have the layer 3 routing inside between the workloads, and you don't have anything else. At most, maybe you may have a service called access list based on IP port, but we understand, we know it is gone 15 years back. Controlling the IP and port no longer providing security because we know that the applications are running different ports, or one port may mean multiple applications. In this case, we needed to provide the same security what we do in our data center to be provided in the public cloud as well. Our next-gen firewall feature sets, the PAN-OS operating system itself, is consistent from security feature set point of view across the hardware, the VM on private cloud, or on the VM on the public cloud. So if you buy a license, VM license, which is VM firewall from Palo Alto Networks, you can easily take this license and enable it in the public cloud and create the same segmentation in the public cloud. The in-out traffic from internet to your public cloud environment, and you can do the layer 3 segmentation between your workloads. I'm saying layer 3 because in the public cloud, the layer 2 infrastructure 100% managed by the provider. So you have the layer 3 routing capabilities there, and you can do the segmentation at layer 3, make your firewall as the default gateway for your servers, for your segments. Is it enough to secure our public infrastructure, public cloud infrastructure? No, because you don't control the layer 2, and you don't have other tools sitting in between the servers, and you need something that you can control over their language. What is their language in the public cloud? It is API. So we acquired companies and merged with our technologies and provided the Prisma Cloud. Originally the name was Redlock, and we have the next session from our customer that will talk about it. What happened? A short outage of power. Sorry about that. Okay. So that's Prisma Cloud provide us controlling the access to the workload, defining which admins from DevOps, DevSecOps teams can manage which workload, with which rights, controlling the files uploaded to the workloads or to the storage in the public cloud, and also generating reports to check against the compliance, the regulations, to make sure your workload in the public cloud are compliant with the industry that you are playing in. This is a solution that complement our network security approach in the public cloud. It is based on API. The deployment is very easy. As I said, our customer, SoftServe, will talk about it, and they will share their experiences with you. I have a couple of slides more just to show you how it looked like, from the perimeter to the private cloud to the public cloud, the overall design, how it will look like if you want to do the segmentation everywhere, deeper, even to the cloud level. Any question, by the way? Maybe you can take this as an opportunity to talk. Yeah, please. Oh. Thank you, Miroslav.
Thank you. Alex Rahmanov. I have a question. Are your prices for instances, Palo Alto instances in Amazon AWS competitive with solutions that provide exactly the Amazon? I mean, why I need to fire up, for example, Palo Alto instance in AWS cloud instead of using Amazon Shield or something else for protecting the instances?
What Amazon provides is not next-gen firewall if you are asking for the VM. So the next-gen firewall feature sets, if you compare with the standard solution, even Azure provides some security level like firewalling at layer 4. We have all the next-gen firewall functionalities, including application identification, user identification, and having all the updates from our threat intelligence cloud, including the threat prevention, malware protection, URL filtering, DNS security services. So if you compare the two, there is a big difference between them. So it is up to your preference, but from security point of view, there's a big gap between the features provided. But if you are asking for the, let's say, the API-based tools that Amazon or Azure providing for controlling the workloads, every functionality has maybe a different tool, but combining them in one place and having multi-cloud support for securing the workloads, it is again a trade-off between spending time on the operation and complexity or making it easier, centralized, and more visualized.
Okay, thank you.
Okay. Any other? None? Okay. Who moved already to the cloud as infrastructure? How many? Is there any regulation preventing you, or you just not found it compelling from a budget point of view? Anybody using containers? Or container? VMware or any virtualization solution like Cisco ACI? Yeah. Thank you, Andre. So going back to our slides, if you look at the overall picture, it is, next-gen firewall in the perimeter, data center firewall, securing your physical network, and next-gen firewall for micro-segmentation, the Prisma compute securing the containers, and all of them are centrally managed by Panorama except the Prisma compute for now. Even the firewall that you have in the public cloud is also managed by Panorama. We are also providing firewall as a service from the cloud. It's called SASE, Secure Access Service Gateway, Edge. This is also managed by Panorama, and is the next-gen firewall features available in the cloud as a service. So the beauty of this design is you have centralized, consistent across all your network, managed and reported from one location, and can be leveraged for other functionalities. We have sessions after this for XDR, a Cortex XDR, which is the combination of EDR, network traffic analysis, and user behavior analysis. So that logging capabilities also can be leveraged to identify the breaches and respond to them. We provide the threat prevention, the URL filtering, antivirus, wildfire, DNS security services. All the services from our Palo Alto Networks Threat Intelligence Cloud can be provided to all of these firewalls deployed across your organization. So if you summarize, the cost of the breach, if you look at the cost, we need to secure our data centers, our network, and we need to implement the zero trust model at every level, physical level, virtual level, even at the container level, to secure our traffic, the north, south, and the east-west traffic. And we need to make it centrally managed, consistent everywhere, and simply to manage operationally, not complex, so we don't do mistakes when doing the configurations. That's it from my side. Thank you for your time, and sorry for the inconvenience regarding the power outage.
Maybe some more questions to Zeke? Okay. No, в любом случае, очень крутой технар от Palo Alto, он будет весь день в зале, так что если что-то заинтересует, подходите к нему. Мы будем